In this lesson, we will solve radical equations and, of course, equations that have rational exponents, which are the same as radical equations. Whenever you have just one radical, what you're going to do is isolate that radical as we have already in this case. And you're going to take each side to whatever the power or the index is of that radical. So this is an index of 2, so I'm going to square each side. Now what that does is it basically negates the root and leaves you with whatever the radicand was to begin with. On the right side, I of course have m minus 5 quantity squared, which means m minus 5 times m minus 5, which gives me m squared minus 10m plus 25. From here, of course, this is just a quadratic, and we've practiced those a lot. So I would subtract the m from each side, and I would subtract the 7 from each side to leave me with 0 equals m squared minus 11m plus 18. So this is my new equation. If I can, I'm going to factor this. I'm looking for numbers that multiply to 18 that add to 11, which are 9 and 2. So that's going to give me m minus 2, m minus 11, or I'm sorry, m minus 2, m minus 9. And then of course when we solve, we would say that m is 2 and that m is 9. So those are my two solutions, 2 and 9. I can plug those values back in to check. So m would be 2 plus 7, the square root of 7 is, 2 plus 7, so the square root of 9 is 3. So for my first one, I would get 3 on the left side, and then 2 minus 5 would give me negative 3. And as we can see, for the m equals 2, that one is not going to work. So it's called an extraneous solution because when I plugged it back in, it did not work. Plugging in 9 gives me 9 plus 7, which is 16, and the square root of 16 is 4. On the other side, 9 minus 5 is 4, and 4 does equal 4, so this is my only solution. So 3 is not a solution because it's called an extraneous solution because when I plug it back in, it does not work. This question is a little bit harder because as you can see, we have two radicals. So when I have isolated my first radical and I square it, this one's going to get a little bit ugly before it gets better. On the left side, the index of 2 and the exponent of 2, of course, cancel. So I have 1 minus 2x. On the right side, remember that this whole quantity squared essentially means that I have the same thing twice. So let's get rid of the squared and just say we've got these two binomials that I have to FOIL. In FOILing it, that gives me 4, and then plus 2 radical 1 minus x, and then plus 2 radical 1 minus x, and then plus radical 1 minus x times radical 1 minus x, which is a big hot mess, essentially. The left side stays 1 minus 2x. The right side, I have 4. These two combine, so 4 radical 1 minus x's. And then if I FOIL, or if I multiply these two terms, essentially I've got this squared, so it's just 1 minus x. Now let's do more simplification. So when I started, I had two different radicals. Now I just have one, which is great. So what I'm going to do is I'm going to get this one all by itself. So let's move all of this other business, this one and these two, to the other side. So I'm going to add the x to get rid of it. So I had a minus 2x plus 1x gives me a negative x. And then I'm going to subtract 1 and subtract 4. So I'm subtracting 5 from 1. So 1 minus 5 is negative 4. And so this is what I have so far. I, of course, can go ahead and divide by 4 on each side if I want. I'm going to leave it just like this and square it and see what happens. When I square the left side, I again am FOILing. So negative x times negative x is positive x squared. Negative x times negative 4 would be plus 4x, and that would happen twice. And then negative 4 times negative 4 would be positive 16. On the right side, I would have 4 squared, which is 16, and 1 minus x, the square root squared, which is 1 minus x. So now that I have gotten everything outside of the radical, now I've got to do some work to simplify this a little bit. This side, of course, when I distribute, gives me 16 minus 16x. All of this on the left side is 8x squared plus 8x plus 16. If I subtract 16 from each side, it will actually go away on each side. If I add 16x to each side, that gives me x squared plus 24x equals 0. So then I'm going to factor and say x times x plus 24, leaving me with two solutions. X is 0 and x is negative 24. I, of course, would do some work to see if they make sense, so I would plug those back in. So plugging in the 0, I would have 1 minus 0, so the square root of 1, which is 1. On the right side, I would have 2 plus 1, which is 3. And as I can see, 1 does not equal 3. So 0 is not a solution. Plugging in negative 24, I would plug in negative 24 here, which would make it the square root of 49, which is 7. Plugging in a negative 24 here gives me 2 plus 5, which is 7. So negative 24 is my only solution. Here's another question that in this case has an exponent that is a rational. So remember that what this means, if I wrote it as a rational equation, wrote it as a radical equation instead of the format that it's in, would be 2 and then the 6th root of x minus 3 to the 5th equals 64. So this is the exponent, the 6 is the index. We're not going to do it that way, we'll just keep it as a rational exponent. But I will, before I do anything to the rational exponent, I will get rid of this 2 that's out front, leaving me with x minus 3 to the 5/6 equals 64 divided by 2, which is 32. Now, when I am trying to get x minus 3 by itself, I'm going to take all of that to the 6/5. If I do it to one side, I do it to the other. Now, what this tells me is that those 6's would cancel because 1 is on top and 1 is on bottom, and the 5's would cancel, leaving me with just x minus 3 on the left. On the right, I'm going to find what 32 is to the 6/5 power. Remember, I can either take 32 to the 6th and then take the 5th root, or I can take the 5th root of 32, which is what I will do. I'm going to take 32, I'm going to take the 5th root of that, and then I'm going to take it to the 6th. So the 5th root of 32 is 2, and 2 to the 6th is 64. So it gives me x minus 3 equals, and this of course is plus or minus 60, no, not plus or minus, just kidding. Because I'm taking the 5th root, it's just positive. Then I'm going to add 3 to each side, which gives me x equals 67. As always, we should check our answer. So if I take 67 minus 3, that's 64. If I take 64 to the 5/6 in my calculator, I do get 32. 32 times 2 gives me 64, and so 67 works out. So remember, always check your solution. Remember this one, I started to write plus or minus, that was completely my fault. Remember, when you are taking an odd index, it's just the positive. When you're doing an even index, you would do the plus or minus. Here is an application question for us to try with radical equations. We have P, that of course represents principal, invested in an account that earns compound interest annually, that grows to $8, so A represents the accumulated amount, in T years. The annual interest rate R is given by this function. We're trying to determine the annual interest rate, so really we're using this function just as it is and plugging in values. So I'm going to say R equals, the accumulated value is 2375.37. The initial principal was 2,000. To the 1 over 5, because it was 5 years, remember 1 over t, and then minus 1. So really, I'm just going to use my calculator. Now the trick, whenever you're doing a question like this, is to not round until you get to the end of your answer. So in my calculator, I'm going to divide those values, take that whole decimal to the 1/5. If you need help using your calculator, let me know. I'm just going to take it to the 0.2 because 1/5 is the same as 0.2. And then I'm going to take that whole value minus 1, and then I'm going to round it. When I do all of that and I take the 1 away, I end up with 0.034999977, etc. Now I'm trying to determine the annual interest rate. So before I took the 1 away, I had a 1 in front, which of course would be my total rate of return, but the interest rate is the, moving it 2 places, would be about 3.5%. So remember, we're finding it as a decimal, we're turning it into a percent by moving it 2 places. So about 3.5% interest rate, which is decent. In this question now, we're given different values. We're given the principal, we're given the rate, we're given the time. We are not given the accumulated value. So this one will be a little bit trickier to solve. So we're given that the rate is 5%, so I'm going to put 0.05. The accumulated amount is unknown. The principal is 5,000. It's 1 over 6 minus 1. So here I'm trying to isolate the a, and you could use an x there if you wanted, just for simplicity. I'm trying to get that a by itself, so I'm going to start by adding 1 to each side. That would give me 1.05 equals all of this. Now this is to the 1/6. I want to get rid of that, so I'm going to take everything to the 6th. Again, when I take 1.05 to the 6th, I get a decimal that is very long. And I'm going to write part of it here, but really I'm leaving that number in my calculator just as it is. I'm not going to round that number at all. So I'm going to take this very large number in my calculator. I know that in order to get a by itself, now I would have to multiply by 5,000. So I'm going to take not a rounded value, but my exact value in my calculator. I'm going to multiply that by 5,000. That gives me 6,700.478, etc. And of course, we're dealing with money, so it doesn't make sense to have an answer like this. So we're going to say it's $6,700.48, rounding to the nearest penny. Here are 2 questions for you to try on your own, so try them both, press play to check your work. Again, here I'm trying to get m by itself, so I'm going to take everything to the 5/4 power, everything to the 5/4. On the left side, everything goes away and I'm left with m. On the right side, again, I'm going to take the 4th root first. When I take the 4th root of 1/16, that actually gives me 1/2, and it would be plus or minus. And then to the 5th power would give me plus or minus 1 over 32. For the other, I'm going to take everything to the 5th power. That would leave me with x plus 1 on the left. On the right side, -3 to the 5th is -243. I'm going to subtract 1 to get x all by itself, which leaves me with -244. Then of course I would plug that in. I would plug in -244 plus 1 would give me -243. The 5th root of that is -3, and so it checks out, and my solution is -244.